Today's Daily Dose of Math is an example of a periodic function and the type of questions that we might have to answer about a periodic function. Here I have my periodic function and I can see that there's a certain pattern that repeats. When the pattern comes to its end and then starts over again, I have reached the end of a period. And I can see that with this function, my period is 6. That's how many units on the x-axis the function has to go through before it gets to its end and starts the pattern over again. That period number of 6 is extremely useful for me when I'm trying to answer these questions. Now, the first couple of questions take place with low x values, and we can actually see the answers on our graph. So for instance, for A, what is the value of y when x equals 2? I can see by looking at the graph that when x equals 2, y is also 2. And I can answer my question. But I choose to do so using functions notation. F of 2 equals 2, which means the y I get when x equals 2 is 2. For B, I need to decide if the function is positive or negative, that is, above or below the x-axis, between x equals 9 and x equals 10. Even though that's in the second cycle of my period, I can still see it on this graph because the graph goes well beyond x equals 9, x equals 10. I can see that my function is below the x-axis the entire time between x equals 9 and x equals 10. So I can answer my question just by looking at the graph. But I choose to use functions notation. F of 9 is the same as f of 3, which is negative 2, and f of 10 is the same as f of 4, which is negative 1.5. The whole region between f of 9 and f of 10 is negative, so therefore the function is negative in that interval. Things get a little bit more complicated when we look at the rest of our questions, where we're looking at values of y when the x values are 39, 68 or 69, 102, even as high as 124 and 126. We can't see any of those regions of this periodic function on the graph that we were given. But we can use our period to figure out what must be happening and use functions notation to answer the question in a way that is justified. So look at C. What is the value of y when x equals 39? Well, the trick to doing this is I'm going to divide 39 by my period. I'm dividing 39 by 6. My answer is 6 with a remainder of 3. The answer of 6 doesn't matter very much. The remainder matters a lot. Since the remainder is 3, that means that f of 39 is the same as f of 3. And f of 3 is negative 2. So therefore, negative 2 is the answer. Let's look at D. We need to know what's going on when x is equal to 68 and 69. So I'm going to divide both of those by my period. 68 divided by 6 is 11, remainder 2, and 69 divided by 6 is 11, remainder 3. So the remainders of 2 and 3 are the values that I need right now. F of 68 is the same as f of 2, which is positive 2. And f of 69 is the same as f of 3, which is negative 2. So therefore, the function must be decreasing as it moves from positive 2 to negative 2 in that interval. I've answered my question. What is the value of y when x equals 102? I divide 102 by my period 6, and I get exactly 17 with no remainder. That means that f of 102 is the same as f of 6. And I can see in the region of the graph that is given to me that f of 6 is equal to 1. Therefore, f of 102 is also equal to 1. Finally, what zeros exist in the function between x equals 124 and x equals 126? I divide both of those values by my period of 6. 124 divided by 6 gives 20 with a remainder of 4. And 126 divided by 6 gives exactly 21 with no remainder. Therefore, I can say f of 124 equals f of 4, and f of 126 equals f of 6. Since 1, 0 exists between x equals 4 and x equals 6, The 0 that exists there is at 5. Therefore, in the period between 124 and 126, there has to be a 0 at x equals 125. 125 is the 0 in that interval. By dividing the numbers in my questions by my period and looking at what the remainders are, I'm able to visualize what would be happening in the periodic function way down to the right, far beyond what's shown on my graph, and still give correct answers with enough justification. That is today's Daily Dose of Math. Please like, subscribe, and share.